Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is day 6 in our 100 days of Go and Rust. The focus of this episode is going to be collections, meaning just like the basic ways you can store multiple pieces of information in Go and Rust, particularly like array type, listed type structures. Okay, so let's start with Go. Okay, with Go, and this will be the same thing in Rust, like you start off with arrays. Okay, and I can create an array like this. I can say, okay, var, my string array equals, well, I have to type it. So then I would say like string, and then I have to sit there and say like how many spaces in the array. So I'm gonna say it's an array of 5 strings. Okay, and then I can be like equals. Then I would declare an array of 5 strings, and then I would use curly brackets to declare the items in there. So like, hello world, how are you? And if you come from like Python, JavaScript, PHP, Ruby, this may seem like a little weird syntax. If you come from like C, C++, this is very similar or very familiar as far as the use of curly brackets. How are you? Okay, then there's my array, and then theoretically I should format.println. Let's just try printing out the whole array. Okay, and let me switch over to the Go terminal. Okay, syntax error, unexpected, and oh, did I for expected line 21? Oh no, line 10. Unexpected at the end of the statement. So non-declaration statement outside of function body. I forget to close something. Okay, so let's just take a quick look at here. Let's go to arrays. Basic types, short declarations, constants. I'm not seeing it from here. Here we go, arrays. Var A, string, that's pretty much how I did it. Primes. I mean, I could do it, I guess, more straight. Oh, I see. The square brackets are on the other side. My bad. Let's try that again. Imported and not used. Okay, that's right. You can't have unused imports. And see there, I print out the array. Hello, how are you? But the problem with like just a straight up array when you're talking about like Go and Rust is that you can't really change them. So if you've used, again, JavaScript, Python, Ruby, arrays or lists are very easy structures to work with. You can like add stuff inside them with different methods. You can filter them, you can map them. There's all these they're really pliable structures, and they become super, super useful. In this case, not as much. Okay, I can declare it. I have that many spots. I can't add a spot. I can't remove a spot. That's what I got. So if I want something different, then I have to declare a new array with a new size and then copy over all the elements. So essentially, if I wanted to push, it'd be a matter of creating a new array, copying over the existing 5 elements, and then adding the new element at the end. And vice versa, and etc. Which can, those are can be really frustrating. I tried to do that once in C, and it was definitely a lot more work than I expected to create that push function just for a basic array. So there is a structure that makes life a little bit easier, and that is called a slice. Okay, now what a slice is, so notice again, when I declared an array, I actually have to specify size. So I'm saying, hey, I want an array with 5 spots. So it's going to figure out, okay, what is the memory allocation for a string, and then create a sequential allocation of 5 of that. Really 6 technically, because you typically what you do is you have a spot that marks sort of the end of the array. Okay, so basically like 5 bits of items and then the 6th sort of symbol that represents, hey, this is the end of the array. So that way the computer knows like this is where the array ends. Okay, because technically really what this is at the end of the day, what the end of day an array is, it's a pointer to the beginning of the array. So that's why when I sit there and say my stir 0, what I'm saying is take this pointer to the beginning of the array and then move that pointer 0 spots, which is going to be the first item in the array. So that's why arrays are 0 indexed. So if I run that, see, I get the first thing in the array. But if this is the first thing, I would want to get to u, I would want to move the pointer 1, 2, 3, 4 spots. So by moving the pointer over 4 spots from the beginning, I'm actually accessing the 5th element. Okay, and this is why again arrays are generally 0 base, because you're not saying, okay, hey, give me the thing that's in this spot in the line. You're essentially adjusting the location of the pointer, and the pointer always begins at the first element. So that's why the first element is 0, because you're moving it 0 spots. Okay, so that's kind of what that evolved from. Cool. Now, but there is this other structure called a slice, and again, that's how you access elements from an array. That's pretty standard among most languages. So if you've learned any programming language, you probably know that, hey, if there's an array and I want to access an element of it, it's going to be square brackets with an index number. I think there might be like 1 or 2 exceptions. Like I think going back to C and C++, like they're an exception, at least in the declaration. Okay, so now if I want to declare a slice, then I would say var my string slice, and then instead I would use empty curly brackets, and I would just say equals a slice of strings. And see, what this means is that it could be any length. Okay, it's a little bit more flexible. And really what a slice is, represents a slice of an existing array. So under the hood, what's happening is actually allocating an array that's bigger than what you need. So that way, if you do want to add an element, there's a space to do so, and then it can kind of keep rearranging that, creating these like sort of rearrangements as needed. Okay, because there's a whole concept of like length and capacity. So every array has a length, how many items it has, and capacity, like how many actual like memory spots it has. Like let's see if we can work that out in a second. Okay, but let's say I just give this the same thing. I'm going to give this the same items in this slice, and let's see what happens when I print the slice. My string slice, and then I just want to print out the whole thing so we can compare the output. Okay, and see, it's the same thing. Okay, and I can access them the same way. So if I access the first item in the slice, okay, and if I access the 5th item in the 4th item in the slice. Now let's see what happens if I try to access the 5th item, which technically there isn't a 5th item in either slice, or the slice or the array. Okay, I get an invalid array index. This is on the array, so that's not going to work. So let me change that back to 4. Let's see if we get the same error on the slice. Okay, index at a range 5 with length of 5. See, and it's based on the length. Okay, so I can never go outside of the length of the slice or the array. Okay, but notice the error is like a little bit different. Okay, now let's see if we can find the capacity of these things. So let's see here. Let me just use this window. Capacity of Go array. Okay, yeah, that's what I thought. Cap S and len. Okay, so let's see here. Let's show both. So for the array, what I'm going to do is I'm going to do fmt.println. Actually, let's do this. fmt.println. And then we're going to print the length of the array, my stir array, and then we're going to print the capacity. So again, the length, how many items are in it, capacity, sort of like how much memory is kind of set aside for it. Print line cap my stir slice, and oops, I'm doing that in the wrong. It's going to give us confusing results if I do it that way. Okay. And just to make this just decorative, let's just say here, we're going to say the array and put some lines here. And then let's just change this again for the slice. So far they kind of work the same way. I got the hiccups, wonderful. Okay, slice. And let's see the output. Okay, so they both have the same, so initially at least they all have the same thing. So basically they all have a length of 5 and a capacity of 5. Okay. And that's pretty much the deal there. You can do some more fancy things with slice. Like let's see here. I think there's already a built-in method for adding to a slice. So let's see here. Pushing value into go slice. If not, we'll appending to a slice. That's right. Okay. So we can use this append method to add something to a slice. We can't do this with an array. So we can add more than one element at a time. Okay. So I can do something like this. I could just sit there and say append, and I want to append to my stir slice, and I want to append yay. Now the thing to keep in mind is that these are typed, so it's not like a JavaScript array where I can just put in whatever I want. These do have to be, see, like strings. I'm specifying that they are a string. Okay. Yay, evaluated but not used. How did I use that wrong? Let's see here. Append S1. Okay, append master slice. But not used. ¿Por qué, Maria? S equals, oh, I see why. Okay. So here's the deal. When you run this append method, though, it doesn't necessarily modify the existing slice. It returns a new slice. So basically what I would have to do is say my stir slice, my string slice essentially, equals the new version with that's appended. And see, now I get 6 and 10. So you notice that like now the capacity has suddenly increased several spots. Okay, even though the length has only grown by the one additional item. Okay, because that append is giving it some extra capacity for future flexibility and use. Okay, so again, this is just that weird behavior, just to be aware of like capacity and slice when you're working with a slice. I'm trying to remember what other built-in methods do they have. I know they got append. Let's see here, arrays, yada yada yada. Okay, then there's like the make, which is just a function for making a slice. You could just declare a slice, but you can also make a slice if you want to make a blank slice. Okay, and you can just sit there and say, okay, make me a slice of bytes, which are just basically a character, or an 8-bit, was it an 8-bit signed integer, I think, or 8-bit unsigned integer, and make it 5 spots, or give it an initial length of 5. Let's just see here. I'm more interested in methods. Okay, growing slices. Okay, we can copy a slice pretty easily using copy. Okay, so you can make a copy of the slice, which is pretty useful. Okay. So basically, a piece of common operations made easier by built-in copy function. As the name suggests, copies the data from the data source to a destination slice. Okay. So what you have to do is you have to create a new slice, and then you're saying, hey, copy this slice to this slice. So you have to create 2 slices and then run copy. Okay, make again makes a slice. Then there's append. But I don't think it goes anywhere beyond that. Okay. Yeah, for the most part, once you go beyond that, like if you want to do things like you could do in JavaScript or Python, like mapping, filtering, etc., then you either have to rewrite those functions yourself or use a third-party library. So I figured at this point maybe it's now time to explore how to use a third-party library in Go. So I got this one somewhere over here. Where did I put it? Yeah, I think this is it. Let's go back to the top. Yep. Okay. Copy the path to the clipboard. We'll come back to that in a second. Okay, so basically if I want to use packages or use like third-party packages, what I have to do is do like go mod init, and then I think I do have to give it a name here. And generally the name has to be behind the namespace. Usually what you do is you do something like github.com/your username, and then like whatever the repository is. So we'll say like my Go repo. Now I'm not pushing this particular code up to its own repo. So I want to make sure that I still put it in some sort of namespace that's unlikely to be used by somebody else. So generally the recommendation is you do something like use a domain that you have. So I have alexmercedcoder.com, and then just do something like, you know, my Go module. Okay, and just give it a name of some sort. Then I hit enter, and see this creates this Go mod file. Okay, and basically this module, that's the name of my module. Okay, and this is just the Go version. Okay, and now I can install stuff. So what I need is this URL here. Okay, so I can be like go, I think it's like go mod install, then I paste the URL. So basically every library, so if you go to like this website here, package.go.dev, you can look up packages. You're going to copy this URL. Okay, and this is one of many packages that give you all these methods. So, but I then hit enter. Where is it? Go install, like that. Oh, go get, that's right. Oh my god, I am rusty. Okay, go get. So it's like go, you know, I always think of it like, you know, Inspector Gadget, like go Inspector Gadget. So it's like go get GitHub, and then it's gonna go get the thing. So I give it the URL, it goes and pulls the package, and see it adds it to the Go mod file. So notice, see, it's the Go mod file acts as like the package.json is the node equivalent, and go.sum acts as the like the lock file in the sense that it tracks all these things. So now that I have that in here, I can then make use of it. Okay. So now I can be like, let me go mod. I can copy this. And go back to my run file and then import it. And now I can make use of this behind the lists namespace. Now see, it's complaining that I didn't use it. We will in a second. So let's like try some of the methods that we're used to. Okay, we're working with a string. So the way this one works is I want to go to the types, and then I want to do versions of these methods for a string slice. Okay, and then we want to use things like, we'll try out like filter and map. Okay, so again, filter, which theoretically we should do, should return a slice of things that aren't true. Okay, so for example, okay, and essentially here we see k and v, which means key and value. So this is probably going to be the index, and then the value of that index. That's the callback signature, and it has to return a Boolean. So we'll do it this way. Keep it simple. Okay, so we have our size. So we'll say actually I'll just say filtered slice equals, using the walrus operator. And then we're going to use list.map. Okay, and notice I used uppercase map because, again, anything that's in that library should be exported with an uppercase. So list.map. Okay. We'll be using FFT in a second. Usually should have contained this namespace. So we'll see if it keeps complaining. We'll get there. And then we want to use this filter method. So it'd be like lists dot filter. Actually, I want to use filter, and then we have to pass out a func, which is going to get the, we'll say, the index and the value, and we're going to return. Well, should we just say this? If the, actually I don't need the parentheses. If the index is less than 2, then we will return true, else return false. And essentially what the result of this should be to essentially remove the first two items, undefined list filter, undefined index, but we defined it right there. Too many arguments to return, have bool. Okay, let me just take a look here. Okay, filter, string slice. I mean, that looks right to me. Okay, and then let's do fmt dot println filtered slice. And let's just see what I get back as errors. Oops. Go run.go. Okay. Yeah, so it doesn't like the namespace. Let me go back to my Go mod here. Lists. Okay. Let's remember where I'm going wrong here. So let's see here. Using third-party Go packages. And mod.go. Okay, using it. Let's just do a quick summary. Make sure that I. Okay, nope, I'm not gonna worry about all that. Nope. Okay. And that's kind of what I did. And that's what I did. So the only thing that I see that I didn't do is run go mod tidy. So let's try that. Go mod tidy. Okay, but yeah, so that's here in my run.go. I am ringing GitHub Francois Qt. We do have it installed. Something I'm missing here. And see, it uses the namespace. So yeah, we do go get. Okay, let me see how they installed it. Oh, I know why. I know why. Because technically, once you're in a Go module, you don't run the file anymore. You do go run dot. You have to run the folder. Okay, and that's going to run. So here we go. My module, undefined list filter. So I'm still getting the same issue list filter. This is the part I don't where I like Rust over Go. Like Go does like the third-party modules a bit better when using cargo. But let's see, you're getting started with Go modules, and the thing is that you have to be very careful when you're looking at documentation for Go modules, because it's changed quite a bit over the years. Like before, they didn't really have a module system, so there was different like third-party tools to manage modules, and you have to have all your dependencies in this one directory called your Go folder. And that was really annoying because basically you had to do all your work in that folder. You couldn't really like have other places to do work. Okay. Now they have a decent module system, but it's always tricky to just get working the way I expect it to. I always eventually do, but let's see here. Generate vendor directory, Go mod tidy. This command allows you to fetch all dependencies that you need for testing your modules. So let's see here. Module root require, we did all that. Import. Yeah, no, and I did exactly how this is. Yep, see that was the folder I was meaning, the Go path, the Go folder. And before you have to do everything inside of there, once upon a time. GitHub / calendar, Go random data. Okay, so let's see what happens if I comment this out for a moment. See, now it says I don't use it, but when I do use it, it's saying undefined list.filter. Oh, okay, it's saying the method is undefined. So let me go back to the documentation. Where did yeah, I think it went back. Where did I have that? Nope, not here. What's been here? Nope. Ah, here it is. Okay, so here we go, string slice. And it's filter, yes. So do they have an example? See, there's the filter, there's the implementation of the function. I get that. And actually, like, you can see how it does it. See what it does, at first it makes a new slice, and then it loops over it, and then just does, you know, works the way you would expect filter to work. Okay, but why doesn't it recognize the function? I am using uppercase. But if I do lowercase filter, it shouldn't work, but let's see. Okay, filter. Do I need to do like string slice? Okay. Doesn't seem to like that. Let's see if we can if we go to the repo, can we see some example code? Import lists maps. Oh, I see. I see. I need to do this. It's list.slices.filter. Cannot refer to unexported name list.slices. Oh, is it list.slices? Okay, so I think I have to do this. I have to do /slices here. And then I can do slices dot filter undefined. Brr. Okay, so let's see here, because the library is called list, and see it has all these like sub pieces. I want to use the list method, so I want to get all the way down to the list part. So slices. Okay. So let's try that. and it still doesn't quite like it. Let's see here, maybe I need to install that specific library. So let's see here, it's just still this. Oh no, okay, so that it does grab that specific piece. So let's see here, go get, I don't like the way that pasted. So that's one thing like I love about npm is that there's one word name packages. It's really easy to download a package with like npm install. I love JavaScript, but let's see here, go get, okay, that's still pretty quickly. Okay, so here's what I'm going to do. So now let me go back to the examples in the documentation. So let's go to, I want to see filter. Filter is what I'm working with. Filter. So here we go. Some slice dot filter. Var some slice slices dot string slice. Oh. Oh, you have to basically create it as part of its own type. Cause see here, see var some slice equals this string slice type, and then that becomes a method of that type. So that's what we need to do first. So what I need to do is here it would be slices dot string slice. Let me just make sure that's the way we spelled it right, because like we see here, we're typing it in that manner. Okay. And then now I can be like my string slice dot filter func kv key value string. Okay, and again, this is going to be an int. This is going to be a string, and it's going to return a boolean. And then I think we're almost there, expecting a comma. Where is it expecting a comma? Shouldn't be expecting a comma there. Ah. Oh, it's because I'm using colons. Again, don't need colons for typing here. There we go. And then this is not used, we can comment that out. Okay, cool. We did it. Okay. So see, this is why it's important to always read documentation. Okay, so let me just run the file, go run dot, and see, it removed everything but the first two items. Because what did I say here? I say run this function. If the index is less than 2, then return true. So 0, 1, those are going to be true. And then false, 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 those are removed. So those your traditional filter method. And then you have your traditional map method, where I can just be like returns value plus the string of cheese. Okay. And this should be returning a string. There we go. And see how cheese, hello cheese, world cheese, how cheese. So the point is, in Go, like it doesn't give you, it gives you some more flexible data structures. But again, a lot of the methods and functions that you're used to, you're still gonna want to go get from like utility libraries. And this one that I use is not the only one, but this is just one example. Of when you can use to work with arrays in Go. Really, you can do most things yourself by just basically, using make and copy and append. Okay, cool. So we spent quite a bit of time there. Let's head over to Rust. Okay, so boop, boop, boop. Okay, here in Rust, what you have is you have arrays. Arrays work the same way. You do also have slices, but you're going to be using probably vectors more often. Vectors are kind of like what you would use. In the same way you would use a slice, you'd probably use a vector more often. Okay, so arrays would work the same way. So I would say like let my array, which is going to equal, and then I think you have to type this in a slightly specific way. Arrays and slices. Yeah, so you sit here and we say, let me find an array here. Okay, let's go to, I think I want to go to primitives here. Scalar types, compound types, arrays, like here we go. I just want to find an array declaration. Okay. We'll go with the tuples in a second. Well, I'm pretty sure it's just like this. Basically, I would just sit there and say my R equals I32. It's an array of like 5 spots. And that'll equal 1, 2, 3, 4, 5. It might be curly brackets, semicolon. Yeah, we really like just to double check and be sure. Double check. Arrays and slices. Okay. Type length. Okay, so here we go. That is how you do it. Okay. So really the way I would do it is like just modify that right there. I have to specify the type, I32, and then the length. And then there's my array. I can print a single item from it, just like you would expect you could. So I could just be like, I want to print this item, my R0. And I can print out the whole array, print, again using that special version of the thingy to inject values in there. And inject the whole array in there. Okay, oops, that's still go. Let's go over the Rust. Okay. Did I declare that as a tuple? Size array. I mean, I did declare that as an array, but it's saying it's a tuple. Interesting. Let my R equal I32.5. Okay, but it's wanting me to do this instead. Dot 0. Okay. That's what I thought. 0. Okay. Unless accessing an element of an array is a little bit more complicated in Rust, of course, but it shouldn't be. Yeah, so see, like you just access it using 0. So that's pretty much the way I would expect it to be used. Okay, forgetting semicolons. Well, I did forget a semicolon right here. So let my array, R32, let's just go back here. Oh wait, did I use a semicolon? No, I didn't use a semicolon. That's why. The comma is what makes it think it's a tuple. Okay, expecting an array with a fixed size of 5 elements. Oh, I put 6 in there. My bad. See, it's got to be fixed. Okay, and then it works. See, we got the deal. We printed out 1 element. Okay, help convert, and see again, it really likes snake case, so it complains when you don't use snake case. So it technically wants me to do this. But see, my JavaScript tendencies have got me using camel case quite a bit. And then I gotta fix these. And there we go. Okay, so see, I got the deal, and then again, I probably would want to put a new line in here. So again, a new line symbols that. So that way it goes on to the next line. And there we go. Okay, so we printed out 1 item from the array, and that's all fine and good. But if you want all sort of the fancier things you can do with an array, then you kind of want a vector, and even a vector doesn't necessarily do exactly what we think it's going to do, but we'll come back to that. So if I wanted to declare it as another thing I can do is I can create what's called a tuple. And a tuple, again, is going to be fixed as far as its size, but the difference is, notice I had to say that here everything is a 32-bit integer. So there's 5. I can't have a mix of things. What if I do want a mix of things? That's where we'll use a tuple. And in a tuple, that's where the comma was important. Okay, if I want to use a tuple, though, it should be a parentheses. Okay, so it would be like I32 bool string, and then I would say equals 5 false, and then be like a new string, so it's like string from hello world, and that should do that. Let's see if it's giving me any. I don't think it doesn't look like it's giving me any errors. So that's a tuple. Print line, and then what we want to do is inject. So in this case, the indexes are properties of an object. Technically, it's not really an array or a tuple in the way you would experience it in Python. It's more of an object that has keys that match what the indexes would be. So that way, it could store the different types. It's really kind of creating sort of a map with number keys. So in this case, if I want to access the Boolean, it should be this should be my tuple. My tuple. Okay. And we'll say we want to access the Boolean. So that's going to be 2. Well, actually, first let's just do the whole tuple because I used that operator. And print line, just an empty curly bracket, and then use my tup.1, which should be the Boolean. Okay, so let's see here. Does this do what we think it's going to do? And I should put that last semicolon there. Apparently, they'll let that last semicolon slide, but and it does exactly what I thought it would do. It prints the tuple, and I'm accessing the first property. So that's like how a tuple works. This can be a really useful way if you just let's say you need like 100 data structures that have mixed types, and they're all identical. You can just kind of loop and create tuples out of different data. Yeah, so that's a tuple. And then last we'll talk about the vector. Okay, now to declare a vector, we're going to just use the keyword vec. I think it's actually vec. And then here you put in what it's a vector of. So I want a vector, let's say, of strings. Okay, of things of the string type. And then what you do is you're going to use this macro, vec. And I want to say, forget, do we use curly brackets or do we use parentheses after the vec? So let's see here. Do they have an example of vec? Okay. Okay. Yep. Where are the vectors? Okay, let's see here, Rust vectors. So make sure I'm using the macro right. Vectors, Rust by example. Okay. So there we go. We declare the vector. And you could use the collect method. Remember we mentioned the collect method earlier, so that's one way I could have done it. Or you could use the macro like this. And that would use square brackets. Okay, so I could do it like this. I forget, was that uppercase? No, lowercase. So in this case it would just be vec, and then I would just say string from hello world, because we're using, again, I'm not doing str, I'm doing string, which is the built-in sort of object type. Okay, so string from cheese, etc. I think we got the point there. And then let's try to print it out. And again, this is going to be my vector. So So my vec. And then I'm going to print, I'm going to use print line because that way I don't have to put in the new line character. And first let's actually print out the vector. So again, to print out like some sort of collection type, we need to use the colon question mark. And then we can do my vec. And then print line. Okay, my vec 0. Let's see how all that works out. Okay, and see that works the way we expect it to. So you printed out the vector and then print out the particular item from the vector that I wanted. Cool. So I mean that's like the fun part of like vectors. And the cool thing is that vectors have methods like push that you're used to from arrays, so you can push values into it. So you don't have to worry about like doing that. Now again, if you want to like do more iterable type things like map and filter, there's where we have to start using this like iter method. Okay, that turns it into an iterable. Okay, but the basic like length. So here's like a length of a vector to get the pop a value off of a vector. It has some of those basic modules, but put in there, and any of the more iterable type things. Again, in Rust we always convert to this iterable type and then collect back into wherever we want the end result to be. So, and again, just to show another way I could have done this is again we could have done the parentheses. And then done dot collect, because then what happens is that it's generating essentially a tuple. Here really what I'm doing is I'm specifying like a tuple, but then I'm saying, hey, take this tuple and turn it into a vector strings, and that also does the job. I should end up with the same result, but I don't. Let me just see why. The method collect exists for tuple string string, but its trait bounds were not satisfied. Called on string string due to unsatisfied trait bounds, which is required by @mute string string iterator. Okay. Let me just see again the example that they shared with declaring it that way. Collected, but they did that with a number. Okay, well, I like using the vec macro better anyways, but required by @mute. Probably needs me to declare the variable mute. Is that part of it? Okay. Do I need to turn this to an iterable first? Let's see if it lets me do that. Okay, method not found in string string. Okay, well, whatever. Not going to stress that one out. Okay, but again, if you wanted to do things something like a map, these are all methods of like an iterable, and so you can see here like you can iterate over it. So see, they turn it to an iterable, then they enumerate. Okay, and what we can do is you see here they're looping over it. So this would be sort of like the for each loop. For a vector. So you do iter. Okay, and then you can also do it in a mutable way. Now if you wanted to map the way that would work, just get back to VS Code. Print line. Okay, so first again, we just say vec string from cheese, and then I would make that an iterable, and then we would do dot map, and then we would do x, which equals one item in the array, and then we would return x plus cheese. Let's see if that lets me do that. Okay, and then what I want to do is print that vector. So print my again, we have to put that in there, comma, my underscore vec, put the semicolon. Let's see here, Rust, will you let me do this? Probably not. Yep. Okay, so let's go through the different errors and address each one by one. Okay, cannot be used to concatenate two at strings. Okay. To create an own string from a string reference, it appends the string on the right to the string on the left. Okay, so basically what I want to do is do like dot to owned. So because again we need to create like a copy of the string, because again it's just a pointer to a string, so it's not owned. This requires ownership on the left. Oh, I need to do it the other way around. See, I love the Rust compiler. As complicated as the language is, the Rust compiler gives very helpful suggestions. Okay, now let's just see if it still gives me that issue. Okay, so I have two errors. I fixed the first error. Second error, expected struct vec found struct map. Vec ended up creating a map. Oh, because I need to collect. Dot collect at the end. Let's see if that fixes that. Okay, and then we have one error now. Vec string cannot be formatted with a default operator. That's right. We need to do this. Use that operator. And do we get where we want to be? Yes. See, we mapped it and we appended it. Okay, so again, if I were to increase this vector with a few other things, cheese, blue, okay, that's how you would use like a lot of these iterable methods. So again, I would basically take the vector, convert it to an iterable, then use like map or filter, pass in the function, and then do a collection. Okay, and then let's try filter. So like say I want to just filter out just cheese. Okay, so then we change this like to filter, and actually let's just filter out everything but cheese. Like I just want blue. So we'll say does x equal cheese. I'm not sure if I can do exactly a comparison of strings like that, but we'll find that in a moment. Yep. Okay. Value, let's see, here we go. Implementation for at string. Help, the trait partial quality is not implemented for at string. Required because the requirements on the implication for at string. Okay, so that gets into sort of again certain things have certain traits where we can actually use equality in them. So I think there is a method for comparison. So let me just let's look that up. Rust string comparison. Okay. Let's see here. String equals string from apple. Okay, that's apple that equal at banana. Okay, so we can use that. So let's try that out first. So does x dot equal cheese or blue? Okay. Value type vec string cannot be built from iterator item at string. A value of type vec string cannot be built from an iterator. Oh, here we go. EQ, no implementation for at string. What if I do this? To owned. So that way it's no longer a borrowed string, a pointer. I think that might fix that. Is that what it's going to recommend me to do? It's not a string. Geez, the trait is not implemented on at string because requirements. Okay, so let's see here. I still have 3 errors. Now it's just 1 error. collect. From iterator at string. Now here's the thing, can I do toOwned on the iterator? So let's try that out. So that way it's no longer a toOwned dot collect. Let's see here. I know I can do that on a string. Can I do it on the vector itself? That is the question. Okay. No. I mean, let me run .toOwned, which is interesting. Now, if I just do a dynamic type, let's just see what we end up with. And then let's get rid of this, and then just print my vec. Let's put the semicolon over here. Okay. Temporary is value free at the end of the statement. Now this error originates in the macro vec. Consider using a let binding to create a longer lived value. Okay, so let's see here. Let's change that. My vec. Let's see here. Maybe if I do that. No. Value drop while borrowed. So it doesn't want me to collect to something. Dot collect, and then let's try typing it into a vector, but we will use a variable type of vector. Temporary. Or I can just do this. I don't really need this for the moment, because basically I'm going to collect it back to vector anyways. So I can just start off with an array essentially. Print. Maybe it wants me to break it down to multiple lines, so first we'll create the vector. So let's go back to doing a vector, and then we'll make it of strings, and that'll be it for this expression. Then what I want to do is I'm going to say let filter result equal whatever this ends up giving me. We'll just say a vector of some sort. Okay, and this will be my vec dot iter dot filter toOwned equal blue, and then I want to use filter result, because again I need to use snake case filter result, so that way it just doesn't give me that warning and wave its finger at me. Oh, Rust compiler. And then that worked. Okay. So really just want me to break up the expression, doesn't want me to chain so much. Okay, so that's not bad. Okay, so we're learning. I feel like I'm definitely getting better and feeling more comfortable with Rust and Go as we do these things. So this is helpful for me. This is why I'm doing this 100 days video, because again, this is not as much like me teaching as you learning with me kind of thing. But yeah, so that's this video. So again, now you have the basics of like how do you work with collections in Rust and Go, and sort of the variations on how they work in that regard. My name is Alex Merced from alexmercedcode.com. Have a great day and enjoy.